I don't know if you paid attention to my avatar. Like, I got rid of all the pandemic hairs. It was quite fun to, like, everyone goes to this phase, right? Sourdough bread and cutting your own hair. Yeah, so I'm Wietse Venema. I'm an engineer in the Cloud Run team at Google, based out of Amsterdam, and I really like birds. So what's this talk about? It's about two things. It's me sharing how Google improves security for serverless developers with automated base image and runtime updates, and showing how you can do the same with open source tools. I'll unpack everything layer by layer. If you think I'm funny, it's okay to laugh. Like, I'm okay. Even if I'm not trying to be funny, still good. Like, loosen up a bit. So disclaimer first: what works for Google might not work for you, right? So our serverless products have a massive scale and a runtime infrastructure that's specific to Google. However, if you are running operations for hundreds of containerized apps, you will pick up a few things that might be very useful to you in your day job. Sounds good? So first sharing what Google does, then how to reproduce it, and you might learn a few things. So products where Google applies base image updates are Cloud Run with functions and source-based services, and App Engine Standard. So not App Engine Flex, App Engine Standard. For those who's familiar with Cloud Run? Not too many of you. That's good, because then those slides won't be boring for you. So it's the easiest and fastest way, at least I think that, and that's for you to judge, to run a container on Google Cloud. And the main resource is a Cloud Run service, which handles web requests. So you give it a container image, and you get back an HTTPS endpoint. And this service will autoscale in real time. This is important, we'll come back to that later. It will autoscale in real time to respond to all incoming requests. And it also scales to 0 if there are no incoming requests. That's also important. We'll come back to that later. And there's a second resource type, which is a job, right? Can you guess what it is? It runs a container from start to finish. Like, if you feel this tingling sensation of trying to, I can see you there, yeah. So a service is started to serve web requests, right? And a job runs from start to finish. And now there is also a Cloud Run function, which is a source-based service. And this is kind of where this whole talk is about, right? So you deploy a method implementation, a function, instead of a container image. By the way, if you're wondering what happened to Cloud Functions, we recently moved it into Cloud Run. So that's why you'll see me say Cloud Run Functions all the time. Hey, but demos are more fun because they never go wrong. This is the Cloud Run, the Google Cloud Web Console. And if I get keyboard focus here, yes. Oh, wow, this is a new failure mode. Let's reload, maybe that works. Wow. I think someone captured okay. So, Cloud Run. It has this button here, write a function. So I'll click it, I get to configure it, give it a name. What shall I call it? Hamburger. I can pick a runtime, so that's Node, Java, Python, a bunch of deprecated runtimes, PHP. I'll stick with Node because that's something which is easy to comprehend. I'll allow unauthentic invocations, and well, that's it. I'll create it. If this takes too long, I have an already deployed one ready for you, so stay with me. So there's your method implementation, right? So hello HTTP, it says hello world. I can save and deploy this, which I'll do. So now I'm deploying this method. I'll take a look at what happens in the background. So it says it's building my function into a container. So I can look at the logs. I will upload the source to cloud storage and launch the builders. So we'll wrap this function method in a web server. The web server is getting containerized. No Docker file required. I'll let this spin for about 2 minutes, but I know you're busy and don't want to wait for that. So I'll go to my deployed function, which is here. Hello node, good name. And look, you will see a YAML here that looks suspiciously like a service resource description. It's, in fact, very, very similar. And there's one thing here, a base image. So this base image is being applied, and there's a container image, right? So this is the proof that the method gets turned into a container image. And there's this runtime class name that enables base image updates. Okay. Like this? Not very excited. This is ContainerDays. Serverless functions. Bear with me. Bear with me. So let's break this down into reproducible steps, because now it gets interesting, right? So you can reproduce building a Cloud Run function on your local machine using open source tools. So step one, I'm not going to show this, but it's creating a web server using the function framework. You scan the QR code, you go to goo.gl/ff. You go to the, how do you pronounce that short code? Like goo.gl is, yeah. Brings you to the GitHub page of this project. So you give it a method invocation, various runtimes are supported. Second step is you take this web server and you containerize it using Google Cloud Buildpacks. And what they do is they turn application source code into a container image without requiring a Docker file. And maybe you really like Docker files. I'm sorry. That's not what this talk about is about. Like, it's fine. I like writing Docker files. They are like shell scripts. Some people really like writing them. So in our demo, let's use those Google Cloud Buildpacks on my local machine, right? So, hello terminal. I have keyboard focus. Here's my, is it readable? We'll zoom in a bit. Whoops. Yeah, there you go. So here's my very simple web service. It's a node service, uses the Express library, responds, starts a web server, responds to incoming request with hello world. Yeah, I'm not really original with that. So let's containerize this. I'll use pack, which is the buildpacks tool. I'll say pack build. I'll choose a builder, and in this case I will choose the Google Cloud Buildpacks builder. I'm getting better at this. Like, I used to make like many mistakes when like all the people are watching me, like fingers start to shake, but it's good so far. So pack build, choose the Google Cloud Buildpacks builder, and build the local directory. It's good that I did this before the talk, because otherwise I would be downloading a bunch of images now. So you can see, I'll stop the scroll for a bit. So you can see that what's happening here. It will have a detect phase. So all the buildpacks builders, the buildpacks that participate in this Google Cloud Buildpacks builder, they will look at the source code and see, hey, is this something I can handle? So the node one will see a package.json file. I'll think, okay, I can install the node runtime. And the npm buildpack will see, okay, package.json. That means I can install those dependencies. So it will build those and add them to a container image. So now I should have a container image that I can run. Docker run it with a port sample node, which starts. Should I try and send a request to it? You believe me, right? This works. I'll quit it. Okay, so this is probably well known, but I'm going to repeat it anyway because I just like hearing my own voice. So every layer in an image, it represents a change to the file system, right? So you start from a base image, it will put in a bunch of files from that you expect to have in a base image. Then you add a few files, remove a few files, run a command that adds a file, and all those layers are overlaid on top of each other and create the final container image file system. So let's look at what my sample node container contains. I'll dive into it. Dive sample node. So dive is a tool, you might be familiar with it, which lets you look at the contents of a container image, right? So on the left here are all the layers of the container image, and on the right-hand side you can see the actual layer contents. So the first one is a base image, as you can see by those files there. Then the next layer adds a bit of configuration, licensing files, and then a layer which adds, there you go, a layers directory. Pay attention to this, I will come back to this later. And it adds the Node.js runtime. Looks good? Okay, I see nods. You're not a very noisy audience, very, very German. Oh, that's, sorry.
I said it first.
Yeah, she was priming me. Like the Dutch are just like that. Okay, so the next layer is npm, and then there is an SBOM, an application layer, which contains all my source code and my node modules. And then there is also a launcher, so I have an entry point to start. Okay, so this container image has a base image, a runtime layer, and an application layer, right? Sort of looks like this. Like, do you like my drawing? Okay, thanks. I need a bit of reinforcement every now and then. That makes it way easier to be here. So both Google and you are responsible for this image, in case you use one of those source-based products, right? So Google provides this base image with the runtime, and the base image, we use Ubuntu. And you provide your application code and your package.json or like your library dependencies. So base images and runtime layers, they need regular updates. Like even if this is a service from a team that is no longer working at the company and still running, no one pays attention to it, it still needs regular updates. Because, well, things break, right? Here's like a short list of interesting security vulnerabilities. Psychic signatures, that was the one where you provided a signature and could trick Java into accepting it, regardless. XSLT, OpenSSL3, not fun. And your code and or its dependencies might need updates too, right? And for you, fixing that is very straightforward, right? Because you have your source code, you update the offending dependency or you fix your bug, and you redeploy, which implies a rebuild. Now, when there's an issue in the base image or in the runtime, what does Google do? It's not rebuilding all the functions, and there are a few reasons why. So a Google triggered, and this has to do with how the products are designed, right? So a Google triggered rebuild is not what developers expect if you're using functions or App Engine, because you are in charge of triggering builds and deploys and not Google. Because what happens if the build fails, right? Then what? They do fail, or worse, the build succeeds, but the code doesn't work. Like maybe some transitive dependency that you didn't pin, hello Python. It updated to a new version and it broke everything, and it still starts, but it doesn't do anything, real story. So that's something we're not doing. But there's another reason why we can't rebuild all the deployed functions. And that's the skill of our platform, because it's very expensive to run the builds for all those functions again. Because there's not just one, there's 3 source-based products running on the same stack. Like on the bottom layer, there's Borg, which was the inspiration for Kubernetes and the name of a subway station nearby. And then on top of it runs the serverless infrastructure. And there's App Engine, which we launched in 2008. So back then, like the first public reports of Borg are from 2005. So I guess I can safely say, without legal getting in my inbox, that App Engine ran on containers when it launched. Cloud Run Functions, the first generation in 2016, and then Cloud Run, which launched in 2019, and it added functions in 2022. App Engine launched 15 years ago? That's a long time ago. Do you remember what the web used to look like back then? Like this probably dates me, but yes, I remember this. And it also means like there's a lot of deployed apps and functions out there, right? Just imagine this vast number. Both App Engine, Cloud Functions, first generation, and Cloud Run are generally available and actively supported. So that should give you a rough idea. Do you have a number in your head? Yeah? Multiply that because of scale to zero. Because customers deploy services and when they stop receiving traffic, they stop paying for them, right? Because it's scaled to zero. You don't pay if it's not running anything. So they just stick around. That service on App Engine in 2009, that might get a request tomorrow. So we can't rebuild all the deployed functions, apps, and services. Yeah, trust your imagination for the number. So this is what we do, and this might not come as a surprise. When a new base image or runtime is available, we take the application layer and we append that app layer to the new base image and runtime. And another term for this is container image rebasing, not to be confused with Git rebase. Okay, so another interesting thing, and this is like how Google does things, image rebasing happens while a container is starting. So instead of rebasing our entire fleet of deployed images ahead of time, which would also be computationally infeasible, Cloud Run resolves the right base image and runtime layer just in time. And this resolving happens during instant startup, right? And there's no impact on startup time because of container image streaming. So instead of pulling the full container image before starting an instance, Cloud Run mounts a remote file system, and it will start the entry point of the container immediately while the container image is still streaming in. And for reasons I can't share, this happens very fast. So that's how we do rebasing. Any questions? So I wondered why image rebasing never broke applications. And you might be wondering this too, right? So in my previous job, when I didn't work at Google, and I wrote that book with the bird on the cover, in my previous job, I used a golden base image from our platform team. And updating it was so risky that we tried to postpone that every time for as long as possible. This doesn't ring any bells, right? And it was thanks to Docker files, right? Because they don't force separation between layers. It's basically a shell script, and from any command, you can change anything on the entire file system. So running an apt-get command or anything else that changes those OS layers will break this rebasable seam. Like it might work, it might break in surprising ways because, well, your app now has a dependency outside of the contract on the base image. Buildbacks, however, they force separation between layers. Because a buildbacks layer, same name, they might have been better if they picked a different name, but hey, a buildbacks layer maps one-on-one to a container image layer. No surprise there. And a directory on the file system. So all you can write to, if you're building your app, is to the workspace directory. If you're adding a runtime, all you can write to is to the /layers and the name of your runtime directory. Wait, what are buildbacks again? I kind of didn't introduce that. So buildbacks are a community build. Familiar with buildbacks? Anyone? Good. Fair amount of people. They are a community-built standard. So they are not invented or created by Google, but it's community-built, right? It's a standard for building OCI-compliant images without requiring Docker files. And it's also a CNCF project with contributors from Heroku, VMware, and Google. Now, Google Cloud Build Packs is Google's implementation of that standard. So they are fully open source and available for a bunch of languages, including PHP. It wasn't a joke. And they're used by, and this is why I think they're interesting, because we're using those in production, right? So you get some like validation that they might actually work. They're used by us in production to build App Engine apps, Cloud Run functions, and those source-based Cloud Run services. There's goo.gl/gcb, GCB, if you want to know more. But what about container image rebasing using Google Cloud Build Packs? There we go. Oh yeah, there's this layer I was talking about, right? Layer directory corresponds to the layer in the base image, in the image. So I'll now do pack rebase of my sample node, which will check if there is a new base image available. And if it is, it isn't because I just built it. But if it was, it would have took my application layer and appended it to the base image. And it works. I hope you enjoyed the show. So one issue though, because all this does is replacing the run image only. So this is what you just saw happening. It also added in the runtime, and that's because how back rebase works. And we'll soon release a new builder to enable also rebasing the runtimes with back. Basically, that's us providing 40 different base images with all the different runtimes. And a builder that knows how to build it, so you can do back rebase and you will replace the thing. Now you can also extend the run images to install packages. How are we on time? Still good? Okay, so I'll turn this into a demo. Because you like demos, right? Yeah, yes. No, not sample. What did they call it? Custom run image. Okay, so here's my Docker file. And I want to install packages. So just pretend there's an apt-get command here in this Docker file, right? There isn't any, but pretend it is. So I'll do Docker build of this. It's based off one of our run base images. Custom run image. Don't forget the directory. And it's done because, well, I did this ahead of time. Go back to my sample. And I'll do pack build builder. You are all like wanting me to rediscover this history feature in Bash, right? Build packs. No, you just watch me type. It's better for understanding. And I will now supply a run image, which is, what do I name it? Custom run image. With all my, oops. Supply the directory. No. Oh, name, yes. Sample node custom. And this will work again. So now I will have a resulting container image that has packages in the base image that I want to be there. And I can rebuild that and rebase it at will. And it failed, of course. Yeah, because the network is shaky. But just trust me on this. It will work. Yeah, so start with the Docker file, build the image, and add those to it. So hey, what was this talk about? It was me telling how Google does things. It might have been useful, might have not been useful. And showing how to do the same thing with open source tools. And you learned about build packs, which are really great for platform teams that support application teams, right? Because some of the benefits include that you can rebase images without requiring a rebuild. So your application teams can build their image, release it every 2 weeks whenever their sprint ends. And you, in the platform team or the operations team, you can release a new version of that image with an updated base image every single day, because you want to stay on top of things. Even if that team that builds the application gets destaffed, right? And there are no longer new releases coming with updated base images. You can redeploy a new image every day. And you won't have to maintain a golden base image or hundreds of Docker files. Like those PRs are fun, right? And you can customize run images with your own packages, or even create your own build packs, which has a bit of a learning curve. Like Docker files are way simpler, but trust me, it's worth it. And there's choice too, right? Because this is not a Google ad. There is Google Cloud build packs, but there's also build packs from Heroku and Paquito. But don't just take my word for it, because this is a great blog post to read from a startup in San Francisco, Doximity, and this is their platform team explaining why they chose build packs over Docker files. The post is from 3 years ago, but it is still a very good overview. And they might just explain it better than I do. That was it.
You know, ending perfectly in time means more time for questions. Yes. Also, I first want to point out that someone actually really did like your humor and, encourage you to go on. They did not want to identify themselves because they use anonymous as their name. So maybe it is not a commonly shared opinion. Anyway.
It's my humor if it's not yours.
That is fine. Yeah,
that's fine.
You can live with that. Okay, cool.
Yeah.
There's a little step. Why does deploying a Cloud Run function or anything on Google Cloud really take so long? Wow. Someone
nice.
is really disgruntled about this one.
Anything. Yeah, I know, because if things take time, it's like a horror movie, but maybe even worse, right? Waiting for things to happen. But actually, did you pay attention when I was doing this live demo, when I deployed the Cloud Run function? Was it that slow? What do you think? It was like...
I don't see nodding, so I guess
I didn't show it complete. Yeah. But it takes about 2 minutes now in Cloud Run functions. You might want to check it out.
All right, thanks for that question. They didn't have coffee in the last break.
Yeah,
I guess that's a little. All right, let's see.
It was a bit like Dutch kind of question.
It was a bit of a Dutch question, yeah. Can you rebase to a custom base image like Wolfie or Tamarine, or just Google provided?
If you use the Google build packs, or if you're into using the Google build packs, it probably makes sense to also use our base images. But I know, try.
Try, okay, good.
It would be possible. You can put in any base image there, right? You can rebase onto scratch and see if it starts.
Fun. Yeah. How to avoid breaking your application when rebasing an image and runtime? At runtime, I guess?
Yes. How to avoid breaking your application. So the idea of...
In general.
In general. Well, while rebasing. So the idea is that this tends to break when you're using Docker and doesn't break when you're using build packs, because it forces this app layer to stay in its lane, right, in its directory. And hey, we have been doing this on App Engine for 15 years, so maybe that's some confidence.
Yeah, I think building on that a little bit is how do you make sure that it does stay in its lane?
How?
Yes.
If you want to do not do build packs.
Yeah.
Yeah, be very disciplined in creating your Docker files. Don't run apt-get. If you need a dependency, put it into your directory where you have your app, because then you would maintain the rebasable scene.
All Right. Sorry. I'm moderating and also figuring out which question to ask next. So if there's anyone that jumps out to you, there's an apology for the German audience. Exactly. That's the one that I asked. How do build packs force the layer separation under the hood?
You can only write to the directory that's assigned to you, the layer or the workspace.
Excellent. What are the requirements on the developers and the platform teams to enable rebasing outside of Google Cloud? I highlight it now for you.
Developers and platform teams to enable rebasing outside of Google Cloud. Not sure how to parse the question. Start using build packs and use back rebase. I think I had a little screen with a bunch of, so you start here, I guess, and then...
we'll need to share the screen again, maybe. Can we?
Yeah, so cloud native build packs, and there's a lot of choice, because there's, Google Cloud's build packs, Paquito build packs, which is entirely community driven, so no vendor attached, build packs from Heroku. So I guess you start there, and then use the back tool to rebase your images. And you can even develop your own build packs. And maybe reading this blog I linked to at the end is a good thing, because it has a lot of explanation and context, and I like because it's not written by a vendor. Also on developer productivity, security, and it's a really good read. Recommended. As
someone working for a vendor, that is high praise. All right. Excellent. We'll do a last one, and then we'll go for a break. Do you see any benefits for Java apps that take more than 30 minutes on their own to build?
Is it a question or a statement?
Maybe a bit of both.
Yes, I guess the benefit would be that you now can run your builds whenever you want to, and rebasing all the time.
All right, thank you for that. Let's go for a little break. We'll be back here 5:30. Yes, thank you.